Hello everyone. In previous lectures, we have discussed about various CPU scheduling algorithms. We have completed first come first serve, shortest job first, preemptive, non-preemptive, priority, preemptive, non-preemptive. Then we moved into round robin. We have completed round robin scheduling. Now, today, let's try to pick that what is our next thing. Now, till now, we have focused on algorithms which are effective for any specific purpose. For example, interactive. If we are having interactive processes, then definitely round robin is quite best. If I'll focus on certain event-driven processes where we require prioritization of processes. Definitely priority is required and priority scheduling is quite effective. If there are simple processes and we do not want to complex our system, then we can move for shortest job first and first come first serve scheduling algorithm. So each and every scheduling algorithm have their own advantage and disadvantage. But do we have such kind of simple environment in our computer system? Do we have same kind of processes in our system? The answer is no. In our system, we have so many different variety of processes. Even as a user, we also do not restrict ourselves in a specific uh, processing aspect. Sometimes we want to listen songs which require uh, different variety of hardware, and on other day we want to move or we want to play a different variety of high-end graphical games, so we want to move for display oriented things. In other way, might be possible that a few of us someday wants to do certain kind of programming, which is the uh, least portion in our uh, everyday work, so which require little bit CPU. So overall, the major thing is that there are various types of processes. So can we use one algorithm to solve all the processes or to schedule all the processes? And that is the main reason that in complex systems, we require certain complex type of scheduling which can incorporate all those aspects. So to deploy these things, there are two basic concepts which were utilized. First one is multi-level queue scheduling and another one is multi-level feedback queue scheduling. Now the thing is, what is concept of multi-level queue and multi-level feedback queue? So today we are going to discuss about the conceptual structure of MLQ and MLFQ. Now we have picked that why we require MLQ. Now let's check one simple architecture that how MLQ scheduling is utilized. So what I'll do, let's check. Suppose I have three variety of processes, and this is just for your example that how uh, anyone can design architecture of MLQ, which says that I can have multiple queues. Now, what does this mean, multiple queues? So for that, I am taking one example. Suppose I have three variety of processes in my system. The first one is system-oriented processes. The second set of process is interactive processes, and third set of processes are, we can say, batch processes. So what I have done, I have divided our processes into three parts. Now, first part, which is system process, which I am assuming that if I have certain processes which are with respect to system, it means they should work on priority basis. We need to decide priority of different processes, and according to priority they should work. For interactive processes, especially user interaction processes, definitely we require to provide interactivity, we require round robin approach. And for batch processing means that they do not require continuous interaction, or they do not have specific priority. They can be executed in the background. So you can say in other terms, the background processes. So for those processes, what I can do, I can deploy FCFS algorithm. Now, there are three different kind of processes, and all different kind of processes can work on different scheduling algorithms. So the thing is how to schedule these processes. So what I'm going to do, I'm going to take one structure like all the system processes will be in one queue. It means what I'm going to do, this is my ready queue. I'm going to divide my ready queue into three parts. So first part is system processes. This is my ready queue, which is having different processes of batch of system processes. Next set of processes is interactive processes. P4, P5, P6, and finally I have batch processes P7, P8, P9, P10. Now, inside this queue or this specific portion, I can deploy priority scheduling. This thing can be scheduled by round robin, and this thing can be scheduled by FCFS. Here I am using priority, here I am using round robin, and here I am using FCFS. But the thing is, I can schedule different processes inside this small queue, but what about overall queue? How I am going to send process to the CPU? So we require another kind of scheduling, and that scheduling will be of queue. Here we have picked the process. So there are two ways scheduling deployed. One is for process, another one is for queue. So here in the individual queues, we have scheduled our processes, and we need to schedule our queue. So what we should deploy here for queue? Suppose I have deployed round robin. Now, as you can see, in complex system, I can have multiple scheduling algorithms at multiple phases and in multiple queues. Now, here round robin says that for each and every queue, suppose I am going to give 50 unit of time. In first 50 unit of time, my system process will get executed and it will execute internal processes with respect to their priority. In next 50 unit of time, what I'll do, I'll execute interactive processes and provide that 50 unit of time equal to all processes which we are having in this queue. Similarly, next 50 unit will be given to these processes but in first come first serve manner. So I have taken simply one example that if I will take round robin, how I can divide it. Otherwise, I can take priority scheduling also, and priority will be given that system processes is having highest priority. So once this queue will get completed, then only interactive process will get chance for execution, and after completion of interactive process, then only batch processes will get chance for execution. So first of all, scheduling of queue will be done. Then on the basis of scheduled queue, inside that queue, depending upon their algorithm, further scheduling of processes will be completed. So here what I am doing, I am using multiple labels. I have divided my queue, or I have divided my processes into multiple queues, and on the basis of these multiple queues, different scheduling algorithms have been deployed. So MLQ is actually a combination of various fundamental algorithms. So that is MLQ algorithm. I hope that you got that how MLQ works. Now the second thing comes that what is MLFQ? What is feedback here? So how it is different from MLQ? And there is very small enhancement has been done in MLQ, and that becomes MLFQ. That is adding the feedback system into the queue, which says, for example, this particular MLQ says that once any process you have picked as a system process, now that queue or that process will not change its behavior. Now, it's not necessary that process cannot change its behavior. It depends upon functionality. There is a possibility that a certain process at the start wants to perform certain CPU intensive program. So that is some kind of, and that is pretty much required for its further step. So currently its behavior is like system process, but after completion of that thing, that process wants to interact, or that process wants to discuss certain things and wants to get things from user. So it becomes an interactive process. So is it right to put any process in one particular queue, and that queue will hold that process for forever? So practically, it's not a good option. So it says that suppose let's take one example that why we should have a frequent movement between queues, that there is a possibility that certain process is currently in system queue, and after certain execution, that process wants to go for interactivity. So what I can do, I can send the process to below that particular queue, which is the interactive queue. So I can have one feedback through which I can send the process from one queue to another queue. And that is the concept of this feedback system. Now, that we have done, that why feedback is required. Now let's take one example. Uh, Example I am going to take, that suppose how I can take feedback system. Suppose I have said that if any process has executed its, suppose I am using a round robin queue to schedule uh, between different queues. So in 50 unit of time, suppose I have said that if any process who got chance two times for execution and still it's not yet completed, then definitely what I'll do, I'll reduce or I'll send that process into below queue. Similarly, in below queue, if certain process has got chance and completed its execution for current environment, so what I'll do, I'll upgrade that process to the upper queue, that this particular process is quite good and it completes its task in given specific time. So I'm going to prioritize that process on the basis of completion of its particular task. So in this way, I can design several feedback mechanisms, and on the basis of that feedback, I'll decide the queue of that particular process. Now, this is something like that generally in our university also, at the end we take feedback from the student. If any faculty member is having very good feedback, then what we can do, we can promote that faculty member to take better classes or to provide better uh, sections who are having good students as compared to the previous sections which are having suppose 8 CGPA, then we will promote that particular faculty member to section which are having 9 CGPA. Or I can say that promotion is in reverse order, that if certain faculty member is quite good in teaching, what I'll do, I'll give that faculty member a section which is having 6 CGPA, so that he can teach and bring those 6 CGPA students to the 8 CGPA. So that is the feedback mechanism. On the basis of that feedback, I am adjusting the algorithm and processes with respect to different queues. So processes are not fixed with respect to any specific queue. Process can change its behavior, and on the basis of that thing, that feedback processes can be moved between different queues. So that is a concept of multi-level feedback queue scheduling. So that's the concept of MLQ and MLFQ. So we have completed almost every basic fundamental of CPU scheduling, started with first come first serve, then moved into shortest job first, then finally moved into priority, then round robin, then MLQ and MLFQ. Please note this thing, that we have focused here with respect to every scheduling, that our CPU is single. So in uni-processing environment, how scheduling can be performed, we have only focused on that thing. So that is all for today. Uh, in next class, we will focus on another topic, that is parallel processing. We will get certain brief introduction of parallel processing, that how parallel processing is performed, what are different ways of it. Now, before I'll sign off from this particular video lecture, uh, let's have one quick review with respect to different CPU scheduling algorithm. In FCFS, we do not have starvation problem, but we have convoy effect. In shortest job first, we have starvation problem. We have one problem of practical infeasibility, that shortest job first cannot be implemented practically without making small changes with respect to adding certain prediction mechanism. Why? Because that is based on purely burst time. Then third we had picked, that is priority. Yes, priority do have problem of starvation, except one specific priority mechanism, which I have not covered here. In certain other lecture, I'll definitely cover, that is known as dynamic priority. So in basic priority scheduling algorithm, yes, we have starvation problem. Round robin, we do not have starvation problem. Round robin is purely preemptive algorithm. First come first serve is purely non-preemptive algorithm. All other which we had picked, that is shortest job first and priority, they have both version, preemption and non-preemption. They have preemptive version of their algorithm and they have non-preemptive version of their algorithm. Then we have picked that in real time system is quite complex and it cannot be handled by single CPU scheduling algorithm. Hence, we require the deployment of multiple CPU scheduling algorithms. Then architecture which is used, that is MLQ and MLFQ, multi-level queue scheduling and multi-level feedback queue schedule, where we deploy our processes or we divide our processes into multiple queues, and inside that queue, each and every queue, different CPU scheduling algorithm can perform its task, and queues can have their own algorithm for scheduling queues. So that is MLQ. Then we have added one feedback system so that processes can be floated from one uh, queue to another queue. So that becomes a multi-level feedback queue scheduling algorithm. So that is all for MLQ, MLFQ, and CPU scheduling algorithms.